So we are going to now go through these computations for one observation, just one. Okay, and let's assume that these are the weights that are given to us. Okay, so these three are the biases: theta 3, theta sub 4, theta sub 5. So theta. So I have the completed network here. So node 1 you have fat, node 2 is salt, and we have the weights. Okay, 0.05 from 1 and 0.01 from 2 coming into 3 with a bias of minus 0.3. Okay, so we will use a regression type function. Okay, again, this function can be anything. Okay, but we are going to use the regression type function to do the computations. So bias is like the intercept. Okay, so bias stands by itself. And then the weights are like the slope coefficients, b sub 0, b sub 1 and b sub 2. The theta is like b sub 0, it's by itself. And then the other coefficients are like slope, you multiply with the value, right? So minus 0.3, then you have the weight, multiply the weight by the value of fat, the input value. So which is 0.2. So we have 0.2. So here is the input value, 0.2 and 0.9 for salt. Okay. So 0.2 goes in here, 0.9, and these two values go here, and we set up a regression-like function and find the input. So that's your combined input. Combined input coming into node 3 is going to be that theta plus the slope coefficient, well, slope within quotation marks, so it's not really slope. It looks like the slope of regression analysis, right? So that one times the input value. Okay, so the input value has to come from that column. Okay, so let's do that, plus the second coefficient times the second input. Okay. So that's our combined input coming into 3. So we have taken a kind of an average of the value of fat and the value of salt coming into this. So that's our combined input. Okay, similarly, if you copy that over, so you're going to get a similar value for node 4 and then for node 5. So these are the inputs. Then we take these inputs and compute an output. So the output function that we're going to use is the sigmoid function, like what we used in the logistic regression. Okay, and once again, there are many alternatives for this. We can take this input and use some other kind of way in which determining the output. So what we're going to do is we're going to do 1 over, okay, so 1 over 1 plus e to the power of minus, okay, we did e to the power of minus L, right? So this is like an L here, the S sub 3 and S sub 4 and S sub 5. So this should be S sub 4 here, I have a typo there. Okay, so that should be 4. Okay, and that should be 5. All right. So now we copy that So those are the outputs going out of 3, 4, and 5. Okay. Now the output of 3, 4, and 5 are going to be the inputs for 6 and 7. So here these 3 output is going to be these 3 input. So what we can do is we need these 3 values down here going in as input to 6 and 7. So we can use transpose function to transpose that D17 to F17 into C24 to C26. Okay. What did I do? Transpose that. Okay, so I have to press Control Shift Enter to enter this as an array function. Control Shift Enter. Okay. So now we have the input set up and we repeat the computations now with these weights. So we have the bias here and the quote unquote slopes here. So take that plus some product of the coefficients with the input values. So the input values, let me absolute reference that. Okay. And then those are the inputs. Now when you do the output, okay, so you get the output. Okay, so that's the outputs. The output here is not probability. It looks like probability, but it is not. Okay. So at the end, so this is just the first step in the first iteration. So this you won't do this at this point. But once you're done, if these are the outputs coming out of the like and dislike nodes, then you will compute the probability. Okay, so you need to normalize this, meaning that this should sum to 1. Okay, so right now there is no guarantee that these two will sum to 1. So we have to make sure that it sums to 1 for it to be considered probability. So we divide that by the sum. Okay, absolute reference that. Now, so you made some adjustments here. So that will be the probability for this row. Okay, so now if you sum it, it will be equal to 1. Okay, but once again, remember, you will do this only at the end, after completing training of the model. Okay, so not in between. So at this point, the first observation is the forward pass for the first observation is over. Now we have to look at the error and do backward propagation. Okay.